Hello, this is Roland Jung from EPLAN Canada. This is the third video of a series of 3 videos. I'm trying to show you a little bit with Phoenix Contact and EPLAN to take most of the benefit you can get out of joining these two systems together. So why is EPLAN such an interesting system to actually work on? Here, these EPLAN certified system integrator programs with 3 different levels. We actually talked a little bit about the first level, making perfect schematics, making the perfect bill of material, exchanging with other people, whether it's the CLIP project, project complete, planning, marking for your marking systems, or get a perfect bill of material out, share with the rest of the world, through eView, EPLAN's cloud solution. That was pretty much the fundamentals of using the EPLAN system, which made it that much smarter, actually. Now, we kicked it up one step on the level 2, where we actually saw that if your panel layout is done in 3D, we call it the digital twin, you can benefit from NC drilling data that can be provided to either a mod center from RITTAL, or you can have your own Perforex machine that will do the drilling to a quality level that nobody else can really do manually. So really, we take it up to the next step. We increase the level of quality in terms of documentation. We showed you also a little bit about the eManage and eView that can be used throughout the cloud and other solutions. And now I want to talk about the last step and to increase to the next step, which is routing and wiring. Now, I'll explain a little bit why this is actually the EPLAN Performance Integrator, the one that is really the most efficient. You have to actually step back one step. We have to take a look a little bit at a study that was done from our counterpart RITTAL, our partners RITTAL, and they pretty much took a standard panel, and this is actually the one that they've used here, and they had it made by several different panel shops and manufacturing companies. And this is the conclusion. We actually estimated the time in percentage that was allocated to the different steps. I mean, everyone knows we have to go through engineering, calculation, quotes, order delivery, that's the sourcing. We had some mechanical work, and then we had to do the integration of the wiring. And here, really, in terms of the panel itself, remember I talked about the cabinet planning as the kitting portion, where you have to plan in all the components, gather them together. Then you had the mechanical processing, which was cutting the ducts, the rails, drilling the holes and the cutouts. And then you had finally to do the mechanical assembly. This is where the labeling came in very handy on the devices. But then you have to do, of course, the wiring. Wiring, on one side, you have to fabricate the wires, you have to land the wires, so the whole wiring, cut, strip, crimp, put the labels on, and then place the wires. And at the end, of course, testing the logistics, getting this whole thing out, and then your panel was built. The interesting thing is that in all these cases, we saw that pretty much half of the time, 49%, half of the time was spent on wiring for tasks that are fairly simple, manual tasks. I mean, obviously, drilling and cutting is a part, but the wiring itself is a very manual task to cut the wires, to unstrip the wires, to put the crimp on top of it, to actually put the labels. It's part of that wiring process that actually could be done in somewhat more of an automatic way. And in this level 3 EPLAN certified system integrators level, we actually evaluate the length of every wire so that eventually a machine can cut and prepare the wires in advance. Of course, at RITTAL, we do have these kind of semi-automatic solutions or automatic solution. The full automatic solution is the WT, but we also have semi-automatic solutions that work with other manufacturers like Phoenix Contact or RITTAL and other systems out there. So depending on the volume, one or the other might be the solution. But the idea is, once you have your data inside EPLAN and you've created your digital twin, you can evaluate the length of your wires, and then you can have these wiring machine service you. This really will cut down on that 49% portion to a significant level, really. So as you know, in EPLAN, we have the schematics. You also know in EPLAN that we have the 3D. Let's put them side by side like this, right? So whatever object you have here, you actually have it here too. Now, what you do have also here is that you have the possibility to do the routing, which now evaluates the exact length of each of these wires. So every wire that you see here, you can click on this wire and it actually has now a specific length. Why? Because I know from where exactly it goes to where it goes, right? It goes all the way across over here to this point here. And this is actually in the schematics, just this small wire here. It goes from CB2 to TB120, which is down there, that small terminal here. So we precisely identify where it goes and the length is calculated. Now, behind this, how does it actually work? Well, obviously, you know that most of these components, once they are placed, let's just hide this one here and you will see very quickly, this is a PLC, a typical PLC. And if I actually connect to a PLC, that PLC will hook up very precisely, as you can see here, on each of these connection points. So this is actually information that is saved at the component level once you get it from the data portal. Now, in some cases, you have components like this one here that eventually is on the data portal, but for some reason, I did not yet download it. So the easy thing, of course, is if it is on the data portal, let's go and check it out first, and let's see what we can do at that point. So we go back to the data portal, we check it out. It most likely will be there. I know this particular part here from Allen Bradley, I believe, is one of the companies among those 400 companies that is there that really did put a lot of work in there. Phoenix Contact, Muir, Wieland, Festo, name it. I mean, you can see them here in the manufacturers, and these are the parts. And this is actually now the part exactly that we are looking at. And technically, if I look at this, I do have the 3D part here. I may not have it in my system because I copied and pasted maybe the portion of the project. I may not have all these accessories, but if I import them, and I only have to import this once, now in a centralized way, I have now all that parts information that, of course, will service me on the bill of material portion because I have now the exact description, the exact order number, but it also will help me when I place the component here because it's going to have not only the exact size, but the exact position depending on where exactly this component is actually set. So here, once it's downloaded and it's complete, let me just see, I mean, we should have access typically to an import button there. And it's going to import all that data into EPLAN. So of course, now that it is imported, the data is now available. So technically, as you know, these components here, you can simply run update parts placement. And because the part is actually now newly imported and the data is there, it will most likely replace it exactly with the right component. And if I try now that I have this, right, and I check it out, it also has like connection informations to detail out where the connections go. You can actually see it here if you look at the connection point descriptions. They may actually have them. Now, that kind of information will actually service you when you do the routing later down the road. Now, some people will say, yeah, well, you know, the component that I have here, unfortunately, does not really have on the data portal the necessary data that I'm looking for, like the 3D. Okay, well, that's not a big thing because you can go on the websites very often of those components and you can find not only like connection data, but you can very often find here some download sections and you can find the step file, which I downloaded. So that means back in EPLAN, all I really have to do in a macro project, you just go in here, you import that particular 3D step file. So here it downloaded it under downloads. It did put it here under this component. I will just import it. Now you will see that this step file, as it comes in, there are 2 or 3 things we have to look at. Number one, this in EPLAN, I'm not really interested in all its individual components. So I'm going to check this out and I can see if it's really one object. If it is one object, okay, this is exactly what I want. I can see this through the logic items, which is perfect. Now I have to figure out, okay, this device, of course, when it's designed, they have a different mindset. But for me, what is my placement area? And it's actually going to be this here. And when I do position it, so basically if I look at this, let me just hide this task settings bar down there. Is it possible to auto hide it? Auto hide it? Where is that? I just don't have it right now. So let's just double click on this. Let's have it like full size because I want to, it doesn't give me this one. So here my view, let me just go there. I have a small view button that most of you actually know, is I'm always interested to see what is my top. This is my power. This is basically this other section. And if this is the way I want to use it, this is perfect, okay? Now, in this particular case here, the second thing that you want to do is you want to precisely say when I move this component, what is actually going to be my positioning. Let's say it's the left-hand side. And then what you can do is you can actually zoom in. Sometimes you can see the connections here. Sometimes you may have to go back to its original website here or image to just see, okay, how are they actually connected? You can see 1, 2, 3, 1 through 8 are actually the numerous one, and 9, 10, 11, 12 are there. So what you do then is, of course, here, let's just take this and, you know, again, just rotate it just slightly like this. It's going to be easier. And then what we're going to do is we're going to place, let's say here, I'm going to try to hit this in the center here to actually define where the wires actually go. So in this case here, it's going to be 9, 10, 11, and 12, which will come out here, 9, 10, 11, and 12. So what I'm going to do is I'm going to insert some connection points I'm going to define. So based on this for the orientation, and then I'm just going to put them here at the bottom level. That's fine enough. And this is going to be 9, okay, connection 9. I do the next thing here for the next one. It's going to be there. That's going to be the connection number 10. I said 11 and 12, 11 and 12, and 12 here, and 12. There we go. Now, just as a reminder very quickly, inside EPLAN, going back to our schematics here, on the schematic side here, if you carefully look, I was actually using the connections 1 and 4, 9 and 11. So 1 and 4 are on the other side. So what I'm going to do here, see that logic item here, it's not the case. So I'll switch over to my logic item again here. And I'm going to look for these ones here. Okay. So technically I can say, where's my next connection going to be? For sure, I can define my ground connection, right? The ground connection will actually go inside here. So it's going to be pointing out to the left-hand side there. And let's put it at the bottom section, maybe on the left side here. And that's going to be my ground. Okay, that's this one. And then I'm going to focus on these ones here. Same thing, let's just rotate them so that we can actually access the correct connections, right? And here the same thing, we will be getting these connections in there. So the first one will be, let's say, my connection number 1. I'm going to just put it on the center there. That's going to be my connection number 1. So if I carefully go and check out the drawing again, I have 1, 2, and 3, and then 4. Now, of course, in this particular case here, I'd have to look at the exact positioning of those ones, but I would say 1, 2, 3, and 4 would be right there. So I'm just going to focus on 1 and 4. The other ones, I'm not even going to do them because I don't want to use them at this point in time. I even prefer that an error actually pumps out. Now, once this is done, so you have your connections, you have to now define on this layout here, you have to define what macro this will be. So this macro, since it's actually a mirror part, you will actually place it ideally in the mirror folder, and the name will be pretty much like that 3D, if you want, kind of thing. And there we go. You know it's an imported step file, and it's done. Now, don't forget, once you have this, it's always a good thing to name your layout space, you know, so that you can recognize what is below it, because imported as layout number 2, that's not really helpful, okay? So once this is done, now we have, of course, the mirror part, which is somewhere down here, mirror. I have a few, you can see here. I can pick more than one if I want to, and I can simply now run the generate macros. This will generate the macros so that I can populate my database, my parts database, to tell me, instead of just knowing the size of the component, I right now will know how it looks like. So technically, if I go back to this component here, this one here, remember, it is all based on a part number. That particular part number has a number of informations. One of these informations, macro related, is here the graphical macro. As you can see, it's actually empty. I'm just going to assign that macro that I just created. Easy to find because I created them in subfolders for each manufacturer, and I can recognize the file that I'm interested in. This is the one. I assign it, I click OK, it actually saves it, and boom, it's there. Now, can I actually just place it by updating the parts placement? Most likely yes, because the way it's actually positioned with the handle on the left-hand side, this pretty much looks the same. So I have exactly what I need here. And there you go. And if I actually do the routing this time here, it's actually going to be sensitive to actually look at the wires to be connected exactly where I need them. So if I take these, I just route them, you will see this transformer will connect exactly where I tell it to connect. Now, I think I did the whole routing of the whole panel because I actually accidentally did a left selection. Similar to other CAD packages, it actually selects everything. So you can see here, we are actually starting the wire exactly where I actually specified it, right? This actually comes out to be exactly on the dot, on the spot where we have decided that the wiring is done. So it's the same thing for most of these other components. And you can see that all the wiring is done. Sometimes even the wiring is done to the side of the panel, because in this one here, I had to actually condense the whole thing a little bit. And I actually placed some components here on the left-hand side. So it's fairly detailed. And now what you can do with these length calculation, not only can you produce the wires a lot faster, but you can now export that data here to some wiring equipment. So smart wiring is one thing where you can actually export it to. So this is the EPLAN PXC RITTAL and FPA 2023. Just going to overwrite that file. And I will actually be able to help my electricians with a very, very detailed view. Now, this is only the start, because from this information we have here, we could also feed a WT terminal, which is a wire terminal from RITTAL, though they will actually print the wires. This is how I call it, because they will cut, crimp, and label the wires and hang it over a certain hanger that pretty much enables then the user to switch over to a tablet, and then he could be in smart wiring. So let me show you how that looks like when I'm actually in EPLAN under smart wiring. So technically all I do is I'm going to create a new page here, hook up to my smart wiring, which is the server I just went to. And once you are here, you name yourself electrician number 1, whatever. Usually it's a name, right? And this is actually for the electrician down on the shop floor. And he would either continue somebody else's job, or he would open this new project that I just created here. And that would be my first instance to produce these wires. Now I have 0 wires done. Maybe I want to work on specific wires first. Let's say I have crimps for 10 American wire gauge. So me, I want to work first on the 10 American wire gauge. You can see they are all identified here, and I can just start by looking at the source, target, the from to. I can even move from one to another, and it actually tells me exactly how the wiring is done. So technically, you go from here, you move over, boop, 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 you go there. Now, the intention is to pre-cut the wires as quickly as possible or by the machine. So either you have a cutter from Phoenix Contact from RITTAL, or you can also have the crimping done automatically. These are crimping machines that actually do exist from different companies. Or you have actually the WT that produced this wire, and it will actually give you on top of a hanger kind of thing where you can just pick up that wire, right? And then just install it. Source, target is installed, status is changed, we switch over to the next wire. So always the same thing here. Plus, another thing that is quite interesting is if you look at this wire and you have any kind of questions about it, you can actually look and focus on the schematics where it actually comes from, because it will tell you these are the two components we just looked at. These are the two, this is the wire where it actually comes from. And if you have any kind of questions, right, you can always mark up that wire and lock it up and say, no, 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 nobody touches this, and you can send a message, or you can just continue and install it. And as you're installing the wires, preparing the wires eventually, well, this actually runs in the background and keeps track of these, right? Now, if for any given reason, the crimps run out and you have to go and get some, but you work on a accord or you work on a time schedule, maybe you'll switch very quickly to your 14 American gauge. And then you just continue. And you say, okay, let's go ahead. Let's do this one here. Cut it to exactly 55 inches. It happens to be a black American wire gauge 14. And then I'm just going to do this one. This one I have to torque. You can see max 2.5 Newton meter. So be careful here. When you actually install it, this one here is probably just a crimp in and you just install it. You can see here we have different Newton information. These are torque information for every one of these wires. So here it's of course a wire that gets installed onto a device that actually requires a screwdriver. So it's not a snip-in, and they actually tell you the torque ratings. So it's really quite interesting what this tool does. Now, even though, let's say it rings the bell, it's 4 o'clock in the afternoon, you stop. So you basically just go out there and you just log out. And you say, okay, done, okay? And you're finished. So basically, you're doing even quicker than this. You just leave it. Now, what happens the next morning, somebody comes in, or even in the next shift, he starts, same thing. So let's say I'm here starting my my EPLAN smart wiring. I say, okay, this is Roland Jung, and I log in. Let's continue the work my colleague electrician just started. Here, EPLAN, Phoenix Contact, that's the name of the project, could be a drawing number, whatever. And I can say, I'm going to open the very last instance, which is the instance 20 you just saw earlier. It goes in there, you can see we have 7 wires out of 132. Now, I may come in here and say, okay, I first want to work on something specific, so I can actually zoom in and say, you know what, I'm really, I really want to look at this portion here, which is my transformer. So let's go back here and let's look specifically for the transformer. So the transformer, if you carefully remember from earlier, it was TR something. So you can go TR search, and then you get all the wires that are actually on the transformer. Whether it's that number, oh, it's already done. See, I don't have to touch it. Transformer pin number 1 is not done yet. It's a 10 red gauge. So let's install it. Boom, boom. And then let's go to the next one. That's basically the TR1, which goes to the TB120. So I'm feeding the 120 volt. You can see this is the neutral here actually, right? And it actually works out. It happens to be the right pin. This is the 120 that comes out of pin number 9. And I will actually wire it up to this time. Where's that component here? It's on the wall. Okay, so basically I'm running off the wall on the side, going down here and moving over here. So if I carefully look at this, I can see I have actually 2 different tracks, 2 different docks. One for the high voltage or 120 and one for the 24 VDC. All this is something that you can pre-arrange inside EPLAN, because technically in EPLAN, when you drill it down to, let's say, your panel and you check it out, I even went and decided that, see here, I have two different docks, one a little bit larger, the D1, and the other one is D1.1. This one here will only handle the 24 volt stuff. The other one will handle the 120 volt, or basically not have any filters. And that makes a whole difference, because you will have the wire that will actually choose the right wire dock to where you go. Now, another thing that is interesting, because I am here in a digital twin, I can now pretty much decide to actually optimize this whole thing. Because let's say we go in here and say we want to stretch this out a little bit. This will actually change my wire length. And if I do have the wire length changed, that will, of course, produce the wires in a different length. All these kind of details, if you wouldn't have here the digital twin, that would be impossible. Another thing that is interesting too, any kind of change, the wire length or even the source and target, can result in some issues because I have installed maybe that particular wire. So if I do change something somewhere, EPLAN is capable of analyzing these changes, very complex topic, and actually will tell the electrician, please remove these wires and reproduce these other wires. And remember, the interesting thing is that because I now have the wire length, I can actually use the automation that was planned in by Phoenix Contact or by RITTAL on the wiring side. Now here, I'll invite you to actually go and contact your RITTAL or Phoenix Contact specialist. Here, the RITTAL has something interesting, is the RITTAL WT terminal. On a very small space here, we can actually place and position and create all the wires automatically and have them pre-printed. But this is only possible once you go to that level. And of course, if I go back to my initial thing where I said, well, 45% of the, or 49% of the time is actually spent on the wiring, well, this I can easily cut it in half and even more, depending on how I make use of these machines. Now imagine cutting half or more of that 49%. That basically means you will be producing that many more projects in a year, because I'm cutting off 1/4 to 1/3 of the time. Imagine, this is huge. This is huge. This is the biggest secret of all. If you know that this is where you spend most of the time, work on that to be efficient, and you'll see this is where you cut down. In average, here we had cases where we cut it down to 34 hours, something that took 58 hours, or even to 24, depending on what level of automation you get. And this is exactly what we are actually qualifying when we look at the EPLAN certification level. When we do the certification here inside EPLAN and we come up and we say, okay, you can save some time here if you work your way up to that efficiency. This is what these level 3 integrators can offer you, is not only a perfect bill of material to start with, a perfect digital twin for NC drilling, but also now for the routing. So routing, remember, means they are manufacturing faster and more accurate, less errors, machines from time to time. If they do the same machine over and over, the two machines will most likely look alike from a wiring perspective. This is the top efficiency level when you combine all these together. That was Roland Jung from EPLAN Canada. Again, ask any of our EPLAN specialists, RITTAL, Phoenix Contact, and we will show you how you can get this work.